Hi, everybody. We are going to get started today on Unit 2.1.1, Introduction to Fractions and Mixed Numbers. Again, this should be our first topic for the MO90 Introductory Algebra class. I want to just kind of give you a heads up that this first week's worth of material sometimes feels pretty easy to some students. If that's the case for you, give yourself a pat on the back. You remembered a lot of your basic information, and take it just as a blessing or as just something really great in your life to say, hey, this feels easy to me and I'm not going to struggle too much for these topics. That's awesome. Now, on the converse, sometimes students actually still struggle with some of these topics because we have not covered these topics in a very long time. We start learning about fractions way back in elementary school, but we just keep building and we learn more and more and more about fractions and decimals and percentages. And sometimes we miss some pieces in there, and so our foundation is kind of weak. And so this first week, we're really building on that foundation again, and then we're going to pick up the pace after our first exam and pick up just kind of the level of topics. So if it feels easy to you, take it as a breather, and if it feels more challenging, please remember that with these videos, it's so great because you can slow me down, use that little settings wheel in YouTube, and you can slow me down. You can also speed me up, depending on how you're doing with the content. I just want to make sure that you are watching the videos and that you're filling in all of your notes, because at some point in time, I will be collecting certain pages, and I don't tell you which pages in advance, but I do expect you to produce those pages in a short amount of time, so that I'm verifying that you have filled in and you've just kind of done your part of every day going through and watching the videos and taking your notes and doing the group activities. And then I just collect just kind of random sporadic pages throughout your notes and throughout your workbook for your notebook check that counts as a larger portion of your homework and in class grades, depending on which category that goes into. So anyway, if you guys have any questions along the way, be sure that you reach out, you contact me. I am more than happy to answer your questions, but you have to advocate for yourself and do that part on your own to say, hey, I've got a question, Liz, can you help me with this? And I am more than happy to help, but you have to do the part too of reaching out and getting the assistance you need. So just make sure you reach out. All right, here we go. We are going to start here, fractions. And again, you should already have this printed out. This was the notes packet that's posted on Moodle. You can get it printed out, and then we're just going to fill in the blanks together here. So fractions are numbers that are used to refer to parts of a whole. And let me get my pen tool ready going here. Parts of a whole, and I am so sorry, my handwriting normally looks really terrible on this, but you're going to be fine. I'll be saying it too. So parts of a whole. So what again that means, if we're looking at a pie chart here, you've got your pie chart here, you've also got your diagram over here. If you're splitting it up and we see this fraction, this bottom number, our denominator, is representing how many equal pieces we're splitting that whole object into. So like over here, if this is a pie, you're taking that pie and you're splitting into 6 equal pieces. And if we're saying, well, what portion of that pie are we talking about? We might say 2 out of 6. Then we start talking about reducing those fractions. And if we're reducing those fractions, we would divide both the numerator and the denominator by 2. And we would reduce it, and it would be 1/3. So that would be 1/3 of the pie that's represented here. Same thing over here. It's 1/3 of this diagram of this rectangular piece over here. So the denominator, again, is your bottom number, which represents the number of equal parts that make up the whole. The denominator cannot be 0. I would highlight this, I would circle it, I would underline it, I would do all the things to help you remember that you cannot put 0 in the denominator. So for example, let's say we looked at something like this, and we're going to say, oh, I'm going to take 6 pieces, and think about what that means. That means that we're taking 0 and we're dividing 0 up into 6 equal pieces. Well, that doesn't make sense, right? Like 0 is 0. You can't divide it into equal pieces because you're starting out with nothing. You have 0 of it. So this situation is what's called undefined. You can even try it in your calculator if you'd like. You can do 6 divided by 0, and oftentimes your calculator will say for error, so ERR, or it'll just say error. It'll actually say the word in there. Conversely, though, if you say 0 out of 6, what that means is that we're talking about my grandmother's pie at Thanksgiving, and we have none of it left. Because why? Because I ate it all, because it's my favorite pie. So we would have no pieces of that pie left that we had taken, and we divided it into 6 very generous pieces. Like, think about a pie, and we only split it into 6 pieces. Those are going to be some healthy pieces. Well, guess what? I'm going to eat them because it's my favorite pie. In fact, for my birthday, I always ask for grandma's recipe. She has now passed, she's deceased, and I miss her a bunch, but we still make her pie, and it's delicious. And guess what? I still eat it. Okay. All right, so the next one here, the numerator is going to be, guess what? If it's not the bottom number, it's going to be the top number. And it is going to describe the number of parts. We're going to have to scrunch this one in. Number of parts that you are considering. And guess what? We already talked about it. Can it be 0? Yes, it can. It can be 0. A proper fraction. So here we're going to talk about our definitions of a proper versus an improper fraction. So here's some 2 definitions for you. A proper fraction is going to be a fraction that is greater than 0, but it is less than 1. So greater than 0, but less than 1. So the numerator is going to be between 0 and your denominator. So that means, anything between 0 and 1 is going to be our proper fraction. So it could be something like 1/5. It could be 3/5. It could be 2/4. It could it be 0 over 2? Could it be 0 over 2? 0 over 2 is going to equal 0. Is that greater than 0 but less than 1? No. So that's not going to be considered a proper fraction. And it says, so the numerator is going to be between 0 and the denominator. And again, our proper fraction has to be greater than the quantity of 0. That means, like, when we've simplified it, or if you take it and you put it into a decimal form, it's got to be greater than 0 but less than 1. Same thing like this. What if we did like 5 out of 5? What do you think about that? So 5 out of 5 would reduce to 1. And so this one is an improper fraction. So that is a non-example. It is not a proper fraction because, again, the quantity of it, once we reduce it, has to be greater than 0 but less than 1. This one equals 1. All right. An improper fraction. An improper fraction is a fraction that is greater than or equal to 1. Greater than or equal to 1. So that means that your numerator is at least as big as the denominator. So we can go back up to this example, right? We've got 5 out of 5, and that equals 1. So that would be an improper fraction because it's going to be 1 or more once we simplify it, right? So this one equals 1. So that could be like 6/5, 7/5. So anything that's going to be like our numerator up here has to either be equal to our denominator or larger than it. So it could be 121 over 2. Anything like that. That's going to be an improper fraction. Those are all, by the way, here are your examples that I kind of wrote in over there. And so then what I would like to say too about these improper fractions, they can also be written as mixed numbers. So again, I'll say that again. Improper fractions can be written as mixed numbers. What about proper fractions? What do you think about that one? Can proper fractions be written as mixed numbers? Sometimes when I ask those questions, I encourage you to like pause the video and then see if you figure out the right answer. Or same thing with the problems we're going to work out eventually. I would pause the video and see if you can do the questions on your own and then restart the video and see how you did. It's a good way to check to see your own level of understanding. And then also it's a good way to like make a note to yourself. Oh, poop, I did this question wrong. Let me make sure I go and ask Liz about it later because I don't understand why I made the mistake. Or you watch the video and you figure out your mistake. All kinds of ways that you can kind of address your own learning and take charge of your own learning. And again, be an advocate for yourself. All right, here we go. Mixed numbers. Definition time. Here's another definition. A mixed number. I don't know if you guys can squeeze these in. You guys should tell me. Are these blanks way too small? They're too small for me. Maybe they're bigger on your guys' version, or maybe your handwriting's smaller. You should let me know. A mixed number is a combination of a whole number. Here's one that's really tiny. Is a combination of a whole number and what type of fraction? This one's going to be a proper fraction. We can imagine a plus sign that's going to be in between the whole number and the fraction. The whole number tells you how many whole items you have, and the fraction describes the part of the incomplete item. So here's some examples. We might have something like 4 3/4. And again, what it tells you is that our mixed number is a combination of a whole number and a proper fraction. So you should always look at that and say, is this a whole number? Yep. Is this a proper fraction? Is the numerator less than my denominator? Yes. So therefore it fits the description, or it fits the definition of a mixed number. And again, it tells you to think about there being like a plus sign in between the 4 3/4. So it'd be like 4 plus 3/4. So that would be like 4 whole pies, 3, 4, and then another 3/4 of a pie, right? So if like I fill these in, so those are all whole pies here. So 4 pies plus 3/4. That's what it's talking about. All right. I think you get the idea. Let's move on. So if we've got 5 2/4, that would be another example. If we have something like 17 1/8, that's another example of a mixed number. Non-examples. So these are not examples of mixed numbers. So we've got something that's like 4 6/6. You can spit on your neighbor with this. 4 6/6 for this. Why is that not? Why would that be not? Why would that be considered not a mixed number? Because go back to your definition. The mixed number is a combination of a whole number and a proper fraction. Is this a proper fraction? Is it less than 1? No. Therefore, this is the part that breaks the rule. And we would rewrite this as 4 plus 1, which gives me 5. 5 whole pieces, 5 whole units. All right, let's look at another one. What if we had something like 5 7/4? 5 7/4. Same thing, right? Like this piece is the piece that breaks the rule. It's not considered, a whole number and a proper fraction. It's an improper fraction. This would be like 5 plus 1 3/4. And then we would combine them and we would get 6 3/4. And we're going to do more practice with that. So if you're like, whoa, what just happened there? We're going to do some more practice with those here in a second. Last non-example. What about, I need a brighter color. Let's do orange. What about just the number 8? Why is that not considered a mixed number? Because it doesn't have the proper fraction attached to it. So it doesn't have this piece attached. So if we made it, the same, it would be 8 and 0/2, but that's a non-example. Okay. We are going to go ahead and dive into the next topic too of unit 2.1.2, proper and improper fractions, and then that'll be the end of this video. So proper and improper fractions. So here are your steps for converting improper fractions to and from mixed numbers. So here are the steps. We're first going to go from improper fractions to mixed numbers. So first, we are going to divide the denominator into the numerator. So divide the denominator into the numerator. So that's bottom number goes into the top number. Then the quotient, so here's some vocabulary if you haven't done this in a while. The quotient is the result of a division problem, or it's the answer to division, right? Result or answer of a division problem. So the quotient is the whole number part of the mixed number. So that whole number part of the mixed number, this part, the whole number part of the mixed number. And the remainder is the numerator, it's going to be this part, is the numerator of the fractional part of the mixed number. So it's going to be like letter B here. And then the divisor, again, here's another good vocab word. The number you divide by is your divisor. So if we were doing something like, I don't know, 15, and we were just doing divided by 2. 2 is going to be your divisor. You're dividing it into 15. So the divisor is the denominator. It's also this piece of the fractional part of your mixed number. So it's C up here. All right, so here we go. It says examples, write as mixed numbers if possible. So some of these we might find out it's not possible, but when would that occur? Well, we're gonna find out. So let's check it out. So our first one, we've got 235 divided by 3. So you may not have done this long division in a long time, and I do require you to do and show me the work for long division. I know you guys can do, I'll do this in your calculator, and many calculators have like the fraction button and it'll just do it for you. On this topic, you have to show me that you know how to do it by hand. And then once we get past this topic, then you can use your calculator, but not yet. Not yet, my friends. So here we're going to do long division. So 3 is our divisor. We're going to put it into 235. So this is your divisor. And you ask yourself again, you look at the first digit. Can 3 go into 2? No. So that's where, I don't know if you guys were taught this. I was taught to put like an X or something over it. Put my finger above it and move to the next one. Now we look at 23 and we say, how many times can 3 go into 23? And you might need to think about that for a minute. If you're not sure, the other thing you can do is you can take 23, put it in your calculator and divide it by 3. Or you just say, okay, well, I know 7 times 3 is 21 and 8 times 3 is 24. So that means 7 is going to be my answer here. So I'm going to say 7 because 8 would be too high. So 3 is going to go into 23 7 times. 7 times 3 is 21. We bring that down. We subtract. 3 minus 1 is 2. And here, right, this is where you do your check. You're like, wait, is 2 less than 3? Because if it's not less than 3, you got to move this number up by 1, right? So come back down. You check 2 is less than 3. Perfect. Keep going. Now that keep going process means I bring down that 5. So we're going to bring down that 5 and we say, okay, how many times will 3 go into 25 without going over? It's like the Price is Right rules. What can we do without, how many times will go in without going over? Here we go. It's going to be 8. So 8 times 3 is 24. When we subtract and we get 1, is 1 less than 3? Bingo. Yes. We don't have any other numbers over here to bring down. So our process is nearly over. So what our final answer is, because you're going to come up here and we say, first divide the denominator into the numerator. Oh, I misspelled quotient. Look at that. Sorry, we've got to fix that. Can't have that. Quotient. And I already got rid of my orange. That's okay. There should be an N right here. Sorry about that, guys. Go back and fix that. You don't want to misspell that. Quotient. Okay, so we've done step 1. The quotient is the whole number part of the mixed number. So that's going to be 78. And the remainder, because that's what we have here, I'm going to say 78 remainder 1. Well, now when I get ready to write up my answer, It's going to be 78. The remainder goes, like it says up here, is the numerator of the fractional part of the mixed number. And the divisor, the number that we divided by, is going to be the denominator of that fractional part. So it's going to be 78 1/3. And that's going to be your answer. And you can always double check, right? Like you can take it in your calculator and put it in decimal form. And you would do 235 divided by 3, enter. And you should get out 78.3 repeating. Then here you can do this. And you can say, well, let me just put this in my calculator and see what I get. 1 divided by 3 should be 0.3 repeating, which means as a decimal, this would be 78.3 repeating. And that's true of this up here as well. So there are some different ways that you can check your work as you're going through this. If you haven't done this in a long time, like I haven't done long division in forever. And so I just think it's kind of fun to practice it and get back at it. All right, so here we go. Number 2. Number 2, we've got 235. We've got the same numerator, but instead of dividing by 3, we're going to divide by 13. So a 2-digit number. So we're going to do 13. We're going to divide it into 235. And they're a different color. So again, you're asking yourself, will it go into 2? No. Will it go into 23? Yes. How many times? Well, once, because if we did it twice, it'd be 26, right? So it's going to be 1 time. So 1 times 13 is going to give us 13, and then we subtract. That should give us 10. Is 10 less than 13? Yes. Bring down the 5. And then you're asking yourself, well, how many times can I get 13 to go into 105? And you might not know. You might be like, I don't know. Let me think about this. Maybe 7 times, maybe 8 times, maybe 9 times. Like sometimes when I've done this in class, we'll just throw out some ideas and like 9. Like some of you might be thinking, okay, what about 9? Because that looks like it's going to be like 90 plus some more. And I'm not sure what the some more is. So let's check it. Let's just try 9 and see if that works. Because sometimes you may not know. So let's do 9 times 3, and that gives us 27. And then I'm going to get 9 times 1 plus 2. So that's going to give me 11. Uh-oh, look what happened. So it's too big. So I'm not going to take 117 from 105. No big deal. So we say, okay, let's just go down by 1. And let's see what happens if instead this is an 8 instead. So we do 8 times 3, which is 24. We're going to put the little 2 up here. 8 times 1 plus 2 is going to give me 10. Perfect. 104 is less than 105. I'm going to bring down the 1. Is there anything else over here for me to bring down? No. So we've got 18, remainder 1. So look at how we expressed our final answer over here. We did 13 is our whole number right here. And it's going to be, 18. Thinking about the next problem already. 18 is our whole number up here. So I'm going to make that an 18. And then we're going to do 1 over our divisor, which is 13. So it's going to be 18 and 1/13 for that. And that's your answer. Okay, so I'm going to give you one to try. So here's one to try. I want you guys to try this on your own. Do it on your paper. I'm going to expect that it's filled in on your own notes. I'm going to give you the answer so you can double check that you're doing it right. So it's going to be 51/4. So this one's going to be on your own. So do the long division, show all your steps. You should be getting 12 3/4 at the end of this. And then I'm just going to make a note on my notes that I have having you guys do on your own. All right, so some special cases that we have down here. Special cases, number 4, 123 divided by 3. Well, that doesn't look like a special case to me so far. So let's check it out. Let's see why it's going to be a special case. Okay, so we say, does 3 go into 1? Nope. Does 3 go into 12? Yes, 4 times. 4 times 3 is 12. Subtract, bring down the 3. 3 will go into 3 one time. 1 times 3 is 3, and that gives me 0. So maybe your answer, we would be writing 41, and wait a second, my remainder is 0. What do I do with that? I can write 0 over 3. Do I need to write it like 0 over 3? No, you don't. You don't have to. So it's just 41. So why is it a special case? Because it's a whole number. We're not going to get a mixed number. So it's a special case because you get a whole number. Number 5. 116 over 14. 116 over 14. So this one, I look at it and I say, oh, I see why it could be a special case. One thing I see right now is that they both end in an even number, which means what? It means we should be able to divide them both by 2. So I'm going to show you something. We could do this one of 2 ways. One way is we can go ahead and reduce it. So what if we reduce it first? And then I'm going to show you another way. So I'm going to have you guys write down both ways. First way is we're going to reduce it and then we're going to divide. And then the next way is I just want you to divide and then reduce. So if we reduce it, I'm going to take out a 2. And I'm going to take out a 2. And when we take that out, you should end up with 58 over 7. So 116 divided by 2 is going to give you 58. You can divide it in your calculator if you want to check me, but that's what you should be getting. So 58 divided by 7. And then we're going to do our long division, 7. And some of you might be able to do this part in your head too. If you've got your multiplication facts down pretty well, you might be able to do that. And you're saying, well, how many times will 7 go into 58? And it should be 8 times because 7 times 8 is 56. And then you're going to get 2 left over. And there's your remainder of 2. And then we're going to have 8 and 2 7s for your answer. So now let's do it like this. Let's do divide first and then reduce. So if we had 14 and we were trying to put it into 116, we already know that it should come out to 8, right? So like we should be getting 8 for this, or that's what we at least think we should be getting based on our previous answer. So let's try it. Let's just try 8. Use our work that we've already done. We know that we should be getting 8 here. So 8 times 4 is going to give us 32. 8 times 1 is 8 plus 3 is 11. And then you're subtracting and you should be getting 4. So then we're getting 8 and 4 14ths. And guess what? Divide by 2. And we're going to get 8 and 2 7s. Bingo, got the same answer. Check, check. Why was this a special case? Because it was reducible. Or you could simplify it if you'd rather say something like that. All right, last one, last special case. 17 over 31. 17 over 31. Why is that a special case? Is that an improper fraction to begin with? No, it's a proper fraction to begin with. So it's already simplified. It's already simplified. It's already proper. Proper and simplified. Okay, let's check the next page and then we're done with this video. Mixed numbers to improper fractions. We are going to multiply the denominator, so the bottom number, right? We're going to multiply the denominator of the fraction by the whole number. Then we're going to add this product. Again, there's a term for you, product, which is the result or the answer of multiplication. So add this product to the numerator of the fraction, and the sum, here's another definition for you, result of addition, result or answer of an addition problem is the numerator of the improper fraction. I actually think for me, it's a little bit easier to go this way, to like go from a mixed number into an improper fraction. Then it says the denominator, of the improper fraction is the same as the denominator of the fractional part of the mixed number. So examples we're going to write as improper fractions if possible. So here's example 1. Example 1, we've got 4 3/5. 4 3/5. So again, looking at our steps here, it says multiply the denominator of the fraction by the whole number. So we're going to do 5 times 4. So I'm going to do the multiplication dot. We're going to add that product to the numerator. So I'm going to keep going this way, and I'm adding now. I'm going to add. And the sum, or my answer, is the numerator of my improper fraction. And then I'm going to put it right back over 5, the denominator I started with. So I'm going to do 5 times 4 plus 3. And yes, I do have you show those steps for this topic. So 5 times 4 plus 3, and that's going to give you 20 plus 3 all over 5, which is going to give you 23 over 5. And again, if you wanted to, you could always change this into decimal form and verify that you did this right. So you should end up with 4.6, right, when you're doing this division and you're putting it into decimal form, or you're going to get 23 over 5 as an improper fraction. All right, let's try another one. So 13 and 5 over 6. So 13, and then you can say in fifth, or 5 over 6. I'm going to say 5/6 is a little bit trickier to say. So we're going to do 13 times 6 plus 5. So 13 times 6 plus 5 all over 6. And you may not know what 13 times 6 is. You can always write it off to the side. You can say, well, let's do a little math. So 13 times 6, 6 times 3 is going to give you 18. 6 times 1 is 6, plus 1 is 7. So we're going to get 78 plus 5 all over 6. Keep going. We're almost done, which is going to give us 83 over 6. And that's your final answer. And you can, again, you can change it into decimal form. You can also do what we did on the previous page and use your long division and check it to make sure you did it right. Excuse me. Okay. Example number 3 is going to be 12 3/8. So this one, again, I want you to do it on your own. So on own, and then you should be getting 99 over 8 for this one. So I'm going to note that on my paper. For you guys to do that one. All right, let's look at some special cases. Special cases, let's say we've got the number 4. And go back up to our directions. Like, what are we even supposed to be doing again? We're supposed to write as improper fractions if possible. So writing as an improper fraction. Can you guys think of a way that we could express 4 as an improper fraction? What would be an idea of that? Writing 4 as an improper fraction. So maybe we did something like 8 over 2. That would be an improper fraction that's going to simplify to the whole number of 4. Or we could do like 4 over 1. We could do something like that. That in the fact that we're somehow expressing the number 4 as an improper fraction, where our numerator is larger than our denominator. All right, special case number 2. What if we had this? -2 5/7. Oh, excuse me. -2 5/7. This one's obviously negative, which is what makes it a special case. This one was a whole number. I did not write that in, but that's why it was a special case. So here's something that commonly gets missed. This is what I see. This is wrong, by the way. I don't want you to do this. I'm just going to show you that this is the wrong way to do this. I will see students go 7 times -2 plus 5 all over 7. And they're going to go out like that. Don't do that because that's going to give you your -14 here. And then you're going to add 5 to it. You're going to get the wrong numerator. So what I want you to do instead, think about putting parentheses around this like that. And then we're going to go 7 times +2 plus 5 all over 7. And your numerator or your fraction is going to be negative. The other thing that you could do is that you could think of it as this is negative and your 5/7 is negative, like that. You could do like -2 minus 5/7 or something like that. And that would still get you the right answer. So I've had students that have wanted to do that too. But I think it's probably easier if you just kind of think about it in terms of putting some parentheses here, convert it into your improper fraction, and then put your negative back on it. So then what we're going to get here, doing it properly, so again, this was not correct up there, we are going to get negative, and we're going to get 14 plus 5 all over 7. And then, so we end up getting, again, we're finishing that up. You're going to get 19/7, and then that answer is negative. So just remember, the other way for you to think about that is that you're thinking about the negative being on the 2 and on the -5. And if we did that, if we kind of look at what we did here, it would be 7 times -2 minus 5 all over 7. Do we get the same answer? -14 minus 5, that's -19 all over 7. Yes, we get -19 over 7. So you can do it this way, but I find that people sometimes forget that that is supposed to be -2, in which case it's wrong, because if you put the plus there, you're going to get the wrong answer. All right. Last one. What if we have something like 2/3? How could we rewrite that as a mixed number? Like, is there any way we could, or not a mixed number, is there any way we can write that as an improper fraction? What do you think? Oh, I misread that one on my paper. It's fine. It's 2/8. It's close. Anything on that one? That one makes it a little bit different. We have to do one step. It's reducible. So it's going to be 1/4. Now what? It's already proper. Already proper. And so we've got two things here that make it a special case. So it's already proper. We can't write it as an improper fraction because it sits as a proper fraction, but it is reducible. So we were able to do that. And that, my friends, gets us to the end of this video. So that's going to be it for this video. Thanks for tuning in.